In the previous session, we already learned about the definition of photoelectric effect. That is, from the light source, we are getting energy of photons. Whenever these energy of photons are falls on this metallic surface, that is nothing but here cathode. So, the already existing electrons are emitted. So, the emitted electrons are sometimes collide each other and sometimes there is no any collisions between the electrons, so they are traveling and reaching the anode. So here we are using ammeter. The purpose of the ammeter is to measure the current. Here we are using voltage, battery and switch. So we already know that. Let's do some simple calculations. That is, if we take energy of photon is 8 electron volts and the work function is 2 electron volts. We already know that the work function definition also. What is that? The minimum amount of energy required to pull out the electron from the metallic surface. Minimum amount of energy required to pull out these electrons from the metal surface. This process is called work function. So here we are taking the value of the work function is 2 electron volts. So if we do the calculation like energy of photon minus work function, we already learned that is always energy of photon always greater than or equal to work function. This is very important key point here. So energy of photon is greater than and work function is less than when compared to energy of photon. See, do the calculation, that is 8 electron volts minus 2 electron volts. The remaining energy is 6 electron volts. Only here we are emitting 2 electrons. Let's see. I will show you in the image. This is the light source. From this light source, the energy of photon value is 8 electron volts. That means we are getting energy of photons 8. So these 8 energy of photons are falls on this metal surface. So only here we have 2 electrons. Only 2 electrons are emitted out. But here we have 8 electron volts energy. What about the remaining 6 electron volts? So here I am saying this is the 6 electron volts. Where this energy goes here. So this 6 electron volts remaining energy goes to kinetic energy. That means this remained 6 electron volts energy is converted into kinetic energy here. So this is the Einstein's photoelectric equation. That is, energy of photons is the sum of work function plus kinetic energy maximum. So here kinetic energy is denoted with 0 to maximum. So here this is the very important formula you need to remember. Energy of photon is work function plus kinetic energy. In this energy of photons we have two values, that is work function and kinetic energy included. So let's see here one more example. That is, if we take energy of photon value is 8 electron volts and the work function is 2 electron volts. But here we have collisions. In the previous problem we don't have a collisions. Here collisions are 0. That means between the electrons, whenever the emitted electrons traveling to reach the anode, there is a collision between the electrons. While traveling, there is a collision between the electrons to reach the anode. But in the first problem, there is no any collision. That's why we are taking here collisions are 0. So in the second problem, we are taking collisions is 2 electron volts. So we have to write like this. So do the calculation. energy of photons minus work function. Value is what? 6 electron volts. In the previous problem, we already know that solution, that is 6 electron volts. But here, how to calculate? Here we have collisions. That means nothing but 8 electron volts minus 2 electron volts, and the collide electrons also we need to reduce. Okay, we need to reduce from these values. So 8 electron volts minus 2 electron volts minus 2 electron volts. So the answer is 4 electron volts. So these 4 electron volts are converted into kinetic energy. Let's see, I will show you with example from this light source. I will show you it clearly. See, from this light source we are getting 8 electron volts. Here I am going to show you with an example. From this light source, 8 electrons are emitted. These 8 electrons are falls on this surface. 2 electrons are emitted out. Only 2 electrons are emitted out. That is, work function is 2 electron volts. So what about the remaining electrons? In this question we have collisions. How many collisions? 2 electrons. So with this collision we wasted 2 electrons. So between the collisions of the electrons, so 2 electrons are wasted. That's why we lost 2 electrons. So the final solution is 8 minus 2 minus 2. Why? Because this is the total energy of photons value and this is the work function value. Only 2 electrons are emitted out. So we need to reduce 2 electrons from this total energy of photons. That is 6 electron volts. This 2 is nothing but collision value. How many electrons we lost? 2 electrons. That's why we need to reduce 2 electrons. The answer is 4 electron volts. This is the final solution. Here we can see some more problems based on the concept of photoelectric effect. Energy of photons value is 8 electron volts and work function is 2 electron volts, and there is a collision, that is 4 electron volts we lost it. So let me know the answer. What is the formula? Energy of photons minus work function minus collisions value, that is 8 minus 2 minus 4. So we have only 2 electrons. So these 2 electrons are converted into kinetic energy. So let's see one more problem. The energy of photon is 8 electron volts. Work function is 2 electron volts. Collision 6 electron volts. So 8 minus 2 minus 6, that is 0. So there is nothing. So that is 0 energy converted into kinetic energy. Let's see the one more problem. Energy of photon value is 5. Work function is energy of photon value is 10. Work function is 5. But here no collisions. So we can directly write 10 minus 5, that is 5 electron volts. So this is the remaining energy. This remaining energy is converted into kinetic energy. Is it clear? Here let me give you the clear explanation about the concept of photoelectric effect. So here we are taking cathode and anode. In this cathode, if you have 10 electron volts, in this 10 electron volts only 4 electrons are able to reach the anode. Why only 4 electrons are able to reach the anode? What about the remaining 6 electrons? So that if we connect a battery to this cathode and anode, a positive charge is developed in this anode. See, if we connect a battery to this anode and cathode, a positive charge is developed in anode because of this EMF of the battery. Because of this EMF of the battery. Battery have EMF. EMF means what? It's nothing but voltage or potential. So this is voltage. In the battery we have voltage. So by this voltage, a positive charge is developed in anode. Okay. So let me say something. If EMF is 0 volts, what happened here? When nothing is attached to this cathode and anode, that means when no any other battery is attached to this cathode and anode, only 4 electrons are reached to the anode. Whenever we add 10 electron volts, that means whenever we add a battery, whenever we connected a battery to this cathode and anode, that means whenever we add 10 electron volts of potential, that is voltage, how many number of electrons are emitted? How many electrons are able to reach this? How many electrons are able to reach this anode? One more electron is increased. That means 5 electrons are able to reach this anode. If we add 20 volts of EMF, then 6 electrons are reached the anode. If we add 10 more volts, that means 30 volts of power to this battery, 7 electrons are reached the anode. If we add, first suppose if we add 80 volts, the total 10 electrons are able to reach this anode. So that's why here we are using the battery. In this battery we have EMF. EMF is nothing but voltage. By this voltage, these all the 10 electrons are able to reach the anode. So that is the purpose of using the battery here. So when electrons flow from cathode to anode here, see, whenever these electrons are flow from cathode to anode, current is produced. Because of only current, these electrons are moved from cathode to anode. So when electrons are flow from cathode to anode, current is produced. So that this current is called photocurrent. This is very important question. You need to remember for short answer type questions. That is photocurrent. Whenever electrons are flow from cathode to anode, a current is produced between them. This current is called photocurrent. Okay. Now I am going to show you one graph. See here. So this is the graph between the photocurrent, EMF in the case of photoelectric effect. So here V0 is the potential. If you take this potential to 0, this is the starting point. If we increase it to 80 volts, if you raise the battery value to 80 volts, the number of electrons are reached to the anode is 10 electron volts. So this is the maximum level. So this level is called the saturation point. So here V0 is the stopping potential. See here, I am going to give you some more information about the photoelectric effect. So here we are changing the battery. That means we are changing the position, polarity of the battery. So we are changing the polarity here, cathode to positive charge and anode to negative charge. In the previous, we are adding the battery like this. That means positive charge is connected to anode and negative charge is connected to cathode. But in this case, we are connecting the positive charge to cathode and negative charge to anode. What happens here and how the EMF will work and how many number of electrons are emitted here. Let's see here clearly. You will get a clear idea. If we take 0 EMF, that means a battery level is 0. If you are not connecting any battery to this cathode and anode, what is the value? Only 4 electrons are reached to the anode. If we add minus 10 volts of potential, minus 10 volts of voltage to this anode, what will happen here? See, only 4 electrons are remained. No more electron is added here. So if we reduce it to minus 20 volts, to the battery, what happens in the anode? In the anode, it collapses one electron, so only 3 electrons are remained. See here, in the previous what happening here? If we add the positive charge to the anode, one more electron is added here. See, if we increase the voltage, if we increase the EMF level to 10 to 20 volts, one more electron is added, and one more electron is added to the anode. But in this case, if you reduce the voltage level, that means if you reduce it to minus 20 volts to the battery, in the anode, one electron is reduced, one electron is collapsed, so only 3 electrons are remained in the anode. So let's see here one more thing. If you reduce it to minus 40 volts, only 0 electrons, the total electrons are collapsed, nothing will be in the anode. So on reversing the polarity from positive charge to negative charge, on reversing the polarity of the battery, negative charge is developed on the anode. So this is the EMF level and the number of electrons are emptied if we change the polarity of the battery. At this value of potential, no current is flows here. So photocurrent becomes 0. What is the photocurrent? I already told you that photocurrent is nothing but when we connect a battery from cathode to anode, a power is developed between the cathode and anode. That means when electrons flows from cathode to anode, by using this battery, a current is produced. Yes or no? So this process is called photocurrent. When electrons flows from cathode to anode, here current is produced. This process is called photocurrent. But in this case, here no current is produced. That's why photocurrent is not working. So photocurrent becomes 0. See, at this value of potential, no current flows from the cathode to anode. So photocurrent here becomes 0. See, no current flows. Why? Because here we are reducing it to minus 40 volts. But so that's why no current is produced. So photocurrent here becomes 0. So this value of potential is called, this value of potential at which photocurrent is 0 is called stopping potential. See, listen carefully. This is very, very important. You need to write in the exams the definitions. See, so this value of potential at which photocurrent is 0, no power supply in between the cathode and anode, at which photocurrent is 0 is called the stopping potential. At this value, this we call it as a stopping potential. Okay, at this, let me say one more time, that is at this value of potential, at this value of minus 40 volts of this potential, no current flows between the cathode and anode. So here photocurrent value is 0. So that's why this value of potential, at which photocurrent is 0 is called photo. See here, I am going to share you very, very important points here. At stopping potential, this is the stopping potential. So at this stopping potential, no electrons flow towards the anode. No electrons flows towards the anode at a stopping potential, but they are waiting outside the cathode. So these electrons are waiting outside the cathode. Here they will wait here, and they will wait outside the cathode and has maximum potential energy, which are having the maximum potential energy outside of the cathode. These electrons has the maximum potential energy outside of the cathode. Why? Because at stopping potential no electrons are flows. Why? Because we are giving the negative charge, so there is no any EMF between the cathode and anode, so there is no any power supply. That's why here this point is called the stopping potential. At this stopping potential no electrons flows towards the anode, so they are waiting, these electrons are waiting outside of the cathode, but they are having the maximum potential energy outside of the cathode. They are maintaining maximum potential energy. This is very important point you need to remember. So, and this only is converted to kinetic energy. This maximum potential energy is converted to kinetic energy when they start flowing towards the anode. So once again they are starting to flow towards the anode. This is only converted to kinetic energy when they start flowing towards the anode. So see here at stopping potential, see, I am going to give you some more information. At stopping potential, kinetic energy is converted into potential energy. So kinetic energy here, kinetic energy is electron volts 0. So this is the formula of kinetic energy in terms of stopping potential. So at stopping potential kinetic energy is called as a potential energy. So kinetic energy is nothing but equals to stopping potential. We already know that potential energy formula. What is the potential energy formula? I will give you here. Potential energy formula is U is equals to Q delta V. We already know this formula, potential energy. Okay. Do you know what is potential energy? We already know that what is potential energy and what is kinetic energy. Let me know here. Let me know in comments what is potential energy and what is kinetic energy. See, I am holding the pen. If I am holding the pen and leaving the pen, if I am holding the pen like this is called the potential energy. If I am leaving this pen is falling very freely, so this energy is called kinetic energy. It's falling without any support. This energy is called kinetic energy. If I hold pen like this energy is called potential energy. Okay. Here, at this value of potential, no current flows. So no current flows here. So photocurrent becomes 0. I'll say again. At this value of potential, no current flows. So photocurrent becomes 0. So this value of potential at which photocurrent is 0 is called stopping potential.